Hi, I'm Mary, and this is another magical math moment. This video is going to examine exponential functions, just basic ones. We're not shifting up or down, left or right, anything like that. We're just looking at basic ones, and this is designed for Algebra 1 students. So this is going to be, assuming you've not seen this before, so it's going to be very elementary if you're an advanced math student watching this. Okay. The general form of an exponential function is y equals a times b to the x. The a value, the number out front, is the y-intercept. If there is no number out front, the y-intercept is 1. B is the exponential rate of change. If the absolute value of b is greater than 1, it's an exponential growth, which means it's increasing. If the absolute value of b is a number between 0 and 1, such as 1/2 or 3/4, the graph will be one of exponential decay, which will be decreasing. Here's something that's kind of new that you haven't heard about yet in Algebra 1. All exponential functions have a horizontal asymptote. So remember, horizontal goes across like that. Asymptote is a line that a curve approaches but never intersects. And it has to do with limits, and we're not going to get into that in this course. So basically, that's kind of the definition we're going to roll with here, is that it gets very close, it doesn't touch. Kind of like you have a sibling and you used to do the little silly thing, we'd be like, I'm not touching you, and you'd like not poke each other. It's annoying, right? That's what an asymptote is. Okay, so let's see. In our first graph, we have y equals 4 times 1/2 to the x. So I know right away that my y-intercept is 4 and my exponential rate of change is 1/2. Since this is a fraction between 0 and 1, I know this is an exponential decay. So we're going to graph this function. When I'm talking about exponential decay, just so you have a general idea, it's going to kind of look like this. So I want to choose a couple of x values where I can easily see what's going on in terms of y, so I have a couple of points. So I might be interested in what's going on when x is -1. Obviously, I'm interested when it's 0, and maybe also 1. So if I plug these values in for x, I have 4 times 1/2 to the -1. You can do the math, or you can use a calculator to help you. Let's see. We get 8. All right. I know the y-intercept is 4, and if you're unsure, 4 times 1/2, 1/2, not 1.2, to the 0 is 4. I can also calculate 4 times 1/2 to the first, and I get 2. So now I have a couple of points that I can go ahead and graph pretty easily. I'm going to go over to -1. 1, 2, 3, 4, 5, 6, 7, 8. 1. Ooh. Let me be more consistent. Try to keep it as consistent as you can. Ugh, that looks garbagey. Hang on a minute. There we go. That makes me feel a little bit better. All right. Let's go ahead and plot our points. So -1, 8 is up here. 0, 4 is here. Right there. 1, 2 is here. Now, as I'm drawing this graph, I like to kind of move my paper around so it looks nice. So I'm going to kind of like make my curve up like that. On this side, it's not going vertical, so be careful, okay? And then this is going to approach the x-axis, but it's never going to touch it. I can also include my asymptote in as a dotted line. This is the line y equals 0. And there's my graph. That's all there is to it. All right, let's try another one. Over here, I know that my y-intercept is 1. This time, the exponential rate of change is 3. 3 is greater than 1, so this is going to be an example of an exponential growth. This is going to be an increasing graph. All right, so I know it's going to look something kind of like that. So I want to get a couple of points that will help me to graph this nicely. I don't know if I want to use -1 because that's going to give me a fraction, and I don't know if I feel like dealing with that. You can do that if you want. You could also do more than 3 points. The more points you have, the more accurate your graph is going to look. So if I have -1 in here as my x, I don't really need to write that one when I type it in. So I've got 3 to the -1. That gives me 0.333. Math, enter, enter converts that over to 1/3 for me. 3 to the 0 is 1. 3 to the first is 3. And then 3 to the second is 9. Remember, 3 to the second means 3 times 3, not 3 plus 3. All right, so now I've got some points. Let's get ready to graph this thing. So we're going up to 9. 1, 2, 3, 4, 5, 6, 7, 8. Oh my gosh, 9, 10. That's not very consistent, but you get the idea. 1, 2, -1. All right, let's plot some points. -1, 1/3, somewhere around here. 0, 1, 1, 3, 2, 9. So once I have my points, I kind of want to move my paper around a little and make this as curvy as it can. This didn't exactly go through this point, but we'll pretend. Notice again that we have an asymptote of y equals 0. In Algebra 1 in the state of Florida, these are the only asymptotes we're going to be dealing with. Now, when you get to other courses like Algebra 2, you'll be shifting these graphs up and down, and that's going to impact your horizontal asymptote. For our purposes here, though, we're not going to worry about that. The last one I want to show you is y equals -3 times 2 to the x. So this one's a little strange because there's a negative. And what you probably remember, hopefully you remember, with negative slopes, it's going to reflect over the x-axis. So normally I would say, oh, this is going to be an exponential growth. It is kind of like a growth that's been flipped over. So it's going to look kind of like that. So let's pull some x and y values, or x values, I should say, to get some y values so we know what this thing looks like. All right, so I've got -3 times 2 to the -1. That gives me -1.5. All right, that's not horrible. Then I have -3 times 2 to the 0. That's -3, which makes sense. That's our y-intercept. Remember, x is 0 at every y-intercept in the world. -3 times 2 to the first is -6. So you can see with those y values, they are in fact decreasing. So here's -1, here's 1, here's 1, 2, 3, 4, 5, 6. We'll try to be as consistent as we can. All right, so -1, -1.5 is here. 0, -3 is here. 1, -6 is there. Okay, so I'm gonna move this because these are hard for me to do upside down. So I'm coming in like so. Hopefully you can see what I'm doing. Yeah, you can. And then it's gonna go through here like that. There we go. And this goes out that way. Now remember, this should not be vertical because then it wouldn't be a function. So be very careful of that when you're graphing these things. This is y equals 0. Okay, I hope that this has been helpful for you and that you understand how to graph these exponential functions a little bit better now. Thank you so much for watching. Please like, share with your classmates so they know how to graph these things too, and subscribe so you can get more math content. Thank you so much for joining me. I'll see you next time. Bye.